Hi everyone, welcome back to the course Everyone Can Code. In this video, we are going to take a look at a problem called Armstrong numbers. Now we are not going to identify if a number is Armstrong or not, but we are going to write a method which returns a string containing all the Armstrong numbers between a range, separating each number by a comma. So let me explain what an Armstrong number really is. An Armstrong number is an n-digit number that is equal to the sum of nth powers of its digits. So let's say if we have a 3-digit number that is 153, it's Armstrong because 1 cube plus 5 cube plus 3 cube add up to 153. So there are a few things involved in this piece of code. First off, you need to find out the individual digits of the number. Then you need to calculate the cube of the numbers. Then once you add up the cube of all the individual digits, you need to compare it with the actual number, whether both of them are equal or not, to identify whether a number is Armstrong or not. Now once this process is in place, then you need to run it in loop to check out for all the Armstrong numbers. So certain method specifications that we'll take care of while writing this function. If given values are negative or 0, we'll return -1. If start value is greater than or equal to the limit value, we'll return -2. And if the input range doesn't contain any Armstrong numbers, we will return -3. In all other cases, we'll simply return the string as specified. So let's move on to the program. So as you see, here is the program structure that you get after downloading the template that is available. Now we have the class Armstrong1, wherein we have taken two numbers, 100 and 125. And we'll generate Armstrong numbers is the function that will return our string when we pass the num1 and num2 variables into it. So generate Armstrong is the place where we'll have the loop that will run through all the numbers and check if each number is Armstrong or not. Now the actual checking of the number is Armstrong or not, for that we'll write a separate function here. Now again, for checking if a number is Armstrong or not, we need three things: sum of power of digits, get digits, and power. So all these three things we'll do separately in different functions and use all of them in the isArmstrong function to check if a number is Armstrong or not. So let's start. Starting off with the generate Armstrong numbers. Now this is the place where we'll deal with our all corner conditions. Starting off with the first one, where we said that if start is less than 0 or if limit is less than 0, return -1. And if start is greater than equal to the limit, return -2. So here are the two conditions for start less than 0, limit less than 0, and start greater than equal to limit. Now since we are getting this error here, let me quickly create a variable result, initialize it to null, and then return the same result string. Okay, so now what we have to do is we have to run a for loop that starts from start and ends till we reach the limit, and in every iteration we have to simply call the function isArmstrong on the current number and add it to the result string if the output is true. So there's going to be a for loop and there is going to be a nest if condition inside the for loop. So as you see, we are running from start till limit, calling the function isArmstrong inside the if condition. Now if this isArmstrong returns true, we add the number to the string, else we move on to the next iteration. Now after this for loop, we need to check if our result is empty or does it actually contain some value. So for that, we write a simple if condition wherein we check the length of the string, whether it's equals to 0 or not. So if it is equal to 0, if you remember, we have to return -3 in that case, that our string is empty and there is no Armstrong number found. But if we have an Armstrong number, we need to go ahead and return the result. But before returning the result, in your last iteration when you add a number here, after that you add a comma also. So you need to get rid of the comma after the last number, which is fairly simple. You take substring of the result string. So result dot substring. The begin index will be 0 as you have to start from 0, but the end index will be result dot length, that is the total length, -1. So when you do -1, the last comma will go out, and then finally you will return the result. So this is how our generate Armstrong number function is looking like. But now we have to write the function that implements the isArmstrong functionality. So in the isArmstrong function, all that we have to do is we have to compare if our number is equal to the number that is returned by the sum of power of digits function. So fairly simple, right? We just compare whether our number is equal to the number that is returned by this function when we pass number here. So this is it for the isArmstrong function. Now we have to calculate the sum of power of digits. We have to write a function to get the digits, and we have to write a function to calculate the power. So let's go ahead one by one into each one of these. Let's first start off with the function getDigits. Here we first convert our number into a string, say s, fairly simple, plus this is it. Now the next step is, since we have to return an array, we need to create an array inside here, but this array will be of the size of the string length. So instead of giving a number here inside int, we say s dot length. Alright, now we need to traverse through our number and get each digit one by one by dividing the number by 10 and using the modulus operator to get the remainder. And then we add that into our array by using the index. So let me write that piece of code here for you. So we have taken an index, initialize it to 0, and inside the while loop, every time we are using a modulus operator, we are adding that remainder to the array digits. And finally, we are returning the array. Now once these digits are returned, we can use this array to calculate the sum of power of digits. So what do we do here is, first off, we need to obtain the individual digits from this digits array. So for that, let's say we have the digits array here, and we call the function getDigits, pass n here. So this will call the function that we just created, getDigits, and will give us the digits array. Now let's say sum, initialize it to 0 initially, and run a for loop that will traverse through the array. And for every traversal or for every iteration in this for loop, inside the for loop, we just call the power function on that particular digit and add it to the sum. And then finally we return sum. So this is how we do it. So we run for loop with int digit in all digits, and sum, we are calling the power function to calculate the power. Now for the power function, we are giving two parameters, the digit itself and digits dot length. So if we are saying 153 number, then this would be 3. Or if the number is 1674, then digits dot length would give me 4. So we'll calculate the power of the digit. Now everything else is done. all we need to do now is write the function par to calculate the power of the digits. So this is going to be fairly simple. What we have to do to calculate the power of a number. Let's say we have to calculate 2 to the power 3. So that means we need to multiply 2 3 times. Or we have to calculate 5 to the power 4. That means we have to multiply 5 4 times. So we need to have a while loop that takes check of the number of times we have to multiply the digit by itself. So we simply have this piece of code here. We have created a variable par, initialized it to 1, and inside the while loop we are multiplying the digit to the par variable that we just created. So let's say in the case of 2 to the power 3, for the first time 3 is greater than 0. We go inside, we multiply 2 to PV. Then 3 minus minus, so that is 2. Now next iteration. Again multiply 2. We get PV 4. And P is again minus minus, that is 1. So 1 is still greater than 0. We again multiply and this time we get PV as 8. Finally we return PV. So this is our power function. Now let's go ahead, save this program and run it. Let's see what input we are giving, 100 to 125. We need to find our Armstrong numbers between 100 and 125. So when we run it, we get minus 3. Now let's go back and see why we are getting minus 3. Result.length double equal to 0. So that means we couldn't find an Armstrong number between 100 and 125. Let's increase our range. Let's say we do it 100 to 500. Now let's save it again and run. We get 4 outputs, 153, 370, 371 and 407. So these 4 are the Armstrong numbers between 150 and 500. I hope you enjoyed this program. Thank you for watching and happy coding.